हेलो दोस्तों, वेलकम टू पायोज एकेडमी। आज के इस वीडियो में हम प्रोसेस डिज़ाइन इंजीनियरिंग का सेकेंड मॉक इंटरव्यू देखने वाले हैं। तो चलो हम इस वीडियो को स्टार्ट करते हैं।
Payos. Learn the smarter way.
You've been working as a process engineer for a few years now. When you start on a new project, what's the first thing you try to understand before doing any calculations?
Before starting any calculations, I always try to clearly understand overall process intent and the design basis of the project. I don't jump directly into the numbers because from my experience, calculations without context often lead to rework later. I carefully review the feed composition, flow rates, operating conditions and design conditions. But more importantly, I try to understand why those conditions are selected. For example, whether the design flow is based on nameplate capacity, future expansions, or specific operating philosophy. I also pay attention to product specifications, utility availability, and any constraints coming from upstream or downstream units. Once this understanding is clear, my calculations become more accurate, assumptions reduces, and discussion with senior engineers and vendors become much more effective.
Have you worked on systems where pumps were a critical part of the operation?
Yes, I have worked extensively on systems where pumps were critical, such as transfer pumps, circulation pumps, and feed pumps. In these systems, I have learned that pump selection is not just about flow and head, but about how the pump interacts with entire system. From a process perspective, I start by defining the required flow under normal, minimum, and maximum conditions. Then I calculate static head, frictional losses, and any pressure requirement at the destination, including control valves or equipment pressure. I also pay attention to the NPSH availability. Ensuring sufficient margin between NPSH available and NPSH required is very important, especially in hot or low pressure services, because cavitation issues can severely affect pump life and plant reliability.
Let's say a pump is frequently tripping in operation. From a process perspective, what are the first things you would suspect?
When a pump is frequently tripping, I first look at whether pump is operating away from its intended design point. Many operational problems come from system changes rather than pump failure. From the process side, I check if actual flow is much lower or higher than design flow. Low flow operation can lead to overheating and vibration, while high flow may overload the motor. I also check suction conditions, whether the suction line has additional losses, valves are partially closed, strainers are clogged, or the liquid level has dropped. Another key point I review is whether the minimum flow recycle line is properly designed, installed, and operational. In my experience, many pump trips are caused by system or operational issues, not by pump itself.
You mentioned line losses. When you size a pipeline, what key considerations do you keep in mind?
When sizing a pipeline, my objective is to achieve balance between hydraulics, operability, and cost. I don't just look at pressure drop alone. First, I select a velocity range suitable for the service. For liquid lines, I ensure the velocity is not too high to avoid erosion and noise, and not too low to avoid settling or poor flow behavior. Then I calculate pressure drop considering both frictional losses and minor losses due to fittings, walls and equipment. I usually use equivalent length method to account for these additional losses. Finally, I evaluate whether the selected line size results in reasonable pressure drop without oversizing. Oversized lines increases capital cost and may create control issues. So the final size should support stable and economical operation.
In any of your projects, have you dealt with high pressure systems that required relief protection?
Yes, I have worked on several high pressure systems where pressure relief was a critical safety requirement. For each equipment item, I systematically identify all credible overpressure scenarios. Typical scenarios include blocked outlet, control valve failure, fire exposure, and thermal expansion of trapped liquid. I don't assume a single case. I evaluate all applicable scenarios and then determine the governing case based on highest relief load. Once the worst case is identified, I calculate the required relieving rate and size of PSV accordingly, ensuring compliance with applicable design codes. Throughout this process, I always treat PSVs as safety device, not as operational control elements.
Sometimes people suggest relying on control valves for protection. What's your view on that?
From both a design and safety standpoint, I don't agree with that approach. Control valves are active devices. They depend on power supply, instrument air, control signals, and logic systems. A PSV, on other hand, is passive mechanical device designed to function even during complete power or instrument failure. That independence is exactly why PSVs are considered the final layer of overpressure protection. Industry codes and standards are very clear that control valves cannot replace PSVs, and relying on them for safety would introduce unacceptable risk.
Have you been involved in designing or reviewing separation equipment like columns or vessels?
Yes, I have been involved in the design and review of separation equipment such as distillation columns and flash vessels. From a process perspective, I look beyond just meeting product purity. I focus on operating margins, column hydraulics, and controllability. I ensure that design does not operate too close to flooding or weeping limits, and that can handle reasonable variations in feed rate and composition. Good separation design should allow smooth startup, stable operation, and flexibility for future changes. In my experience, columns that are designed too tightly often face operational challenges even if they meet design specifications on paper.
One last question. When a vendor sends you a data sheet that looks acceptable at first glance, do you still review it in detail?
Yes, always. I never approve a vendor datasheet without a detailed review, even if it looks acceptable initially. I cross check design pressure, design temperature, flow rates, operating cases, margins, and assumptions against the process datasheet. I also check whether the vendor has considered all relevant scenarios such as normal, maximum, and upset conditions. If I found any mismatch or unclear assumption, I discuss it with the vendor and resolve it before approval. From a process engineer's responsibility point of view, approving a datasheet without proper review can lead to serious operational or safety issues later.
Alright, that gives me a good understanding of how you approach design. Thank you.
Thank you.
Payos. Learn the smarter way.